Hey students, today's notes are on similar solids. We are still in Unit 7 with similar figures, and what I'm getting ready to show you with the similar solids fits perfectly with what we've been doing. Now, before I go on with the notes, I want you to get out worksheet 45, pause the video and go find your worksheet 45, because I told you on worksheet 45 that at the front, the bottom question was going to kind of lead us into these notes. So I want to go over what this bottom portion says. By the way, you can freeze your screen and you can make sure you have all of this down and you have what I have down. What I want to talk about here is it talked about finding the areas of the two triangles. I did have to do the distance formula to get those areas, and I knew that this was the base and I knew this was the height because I checked the slope and the slope, and they were opposite reciprocals. So I knew that in a right triangle, the base is the bottom, the height is the side. You may have not known that, and that's fine. But anyways, the point I want you to get is these are your areas. Okay, so because everything we've been doing has been comparing ratios, what I did was I compared these ratios. And this, when I put it in my calculator and reduce it, reduces to 1 to 4. This is the ratio of the areas. If you remember this whole problem, we multiplied by a scale factor of 2. So if I ask you what the ratio is from left to right, from little to big, it is a 1 to 2 ratio. Scale factors multiplied by 2, the dilation, the coefficient, but the actual scale factor, if I say from left to right, is 1 to 2. And I want you to notice that the ratio of the areas comes from here. Okay, you may not have known any of that, and that's okay. All right, but at least you could have practiced getting the areas and then waited for me to help you with that. So this is what this entire lesson is about. All right, so similar solids have exactly the same shape but not the same size. If you look at this picture here, that's an example. Two solids are similar if the ratio of their corresponding linear measurements, and that is plural for a reason, are equal. The types of linear measurements are everything that's listed here. Okay, we haven't covered circumference yet, so if there's something where it asks you to find the circumference, we're not finding any volumes or surface areas yet. We're going to be given everything we need. We just have to look at the ratios. Okay, so my examples are: determine whether the solids below are similar. If yes, give the scale factor in simplest form. All right, so what we have to do in these two, these are pyramids, okay? In these two problems, we're going to compare all of the pieces. So you can tell by the way it's oriented that the 12 is the height, and it corresponds with the 3. The 8 over here corresponds with the 2, and the 20 corresponds with the 5. You're going to see that everywhere. The 24 corresponds with 20 here. Okay, so 12 corresponds with 10, and so on. So what we're going to do is we're going to write down the ratios from the left to the right. So I know that the 12 corresponds with the 3. You can use color if you want to, but we're going to move away from the color so we can get through these problems a little quicker. I know that the 8 corresponds with the 2, and I know that the 20 corresponds with the 5. Now, you can put all those in your calculator. You do not need to pick up your calculator for this, because I know this reduces to 4 to 1. I know this reduces 4 to 1, and I know this reduces 4 to 1. So because all of those reduce 4 to 1, my answer is yes, the figures are similar. And then it says give the scale factor. This is the bigger one. The bigger one goes with the 4. The smaller one goes with the 1. And these are your answers. Okay, number 2. So we can see how the pieces are matching up. The height right here, and then the length and the width of it's actually a square in the bottom of that rectangular prism. So we're going to look at this 6 corresponding with this 10. We're going to look at this 6 corresponding with that 10. No, you don't have to write it down again. You know it's there twice. And then we do have to look at the 8 corresponding with the 12. Okay, if I was going to reduce these, remember you can put it in the calculator and look at the decimals, or you can look at just the reduced ratio. This reduces 3 to 5, 3 to 5. This reduces 2 to 3. And if you were putting that in your calculator, remember you are simply going 6 divided by 10, and then what was it, 8 divided by 12, and you're looking and seeing that those decimals are not the same. Okay, so the answer to this is no, and we're done. You can't give me a scale factor if there isn't one. Okay, so we have to check all of the linear measurements. Everything in the problem has to be checked. So I want you to check the linear measurements and tell me yes or no. If it's yes, tell me the scale factor. All right, here's your answer. I used 24 with 20. Do not make the mistake of using 24 with 10. Those are not consistent parts. And then I used the 30 with the 25. Reduce those. You could have used 12 to 10 or 24 to 20. Both of them reduce 6 to 5. Remember your scale factor from left to right. If nothing tells you from A to B, you have to go from left to right, or if it's situated where it's top to bottom, go top to bottom. Okay. All right, the next thing. Yeah, this is really easy. Okay, comparing volume and surface area. So if two solids are similar with a scale factor of A to B, then their volume and their surface area ratios are as follows. The surface area, just like we talked about the area here on worksheet number 45, the area's ratios are squared from the scale factor, okay? So what happens is the surface area, or area, if it's a two-dimensional figure, the ratio is squared. And then for the volume, volume is how much would fill the shape. And so we're not finding the volumes just yet. We're just looking at the ratios of the scale factors. And those would be cubed. Okay, so show you how simple this is. So if I'm going to find the scale factor, you can pick, okay, first of all, they have told you these are similar, okay? So any corresponding parts will give you the scale factor. So if I use the height, the altitude, and I just say 6 to 3, okay, then I know that reduces 2 to 1. Okay, so my scale factor is 2 to 1. And I've been writing them like this. If you write it 2 over 1, you have to put the 1 in the denominator to show that it is a scale factor. Okay, the area ratio, we are squaring this. So the area ratio comes off of the scale factor, and that would be 4 to 1. And then the volume comes off of the scale factor, not off of the surface area. And we are cubing it, so we're saying 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. It's that easy. Okay. Let's look at number 5. Okay. So we're going to pick any piece of the problem and get the scale factor. I'm going to use the 4 and the 6. And that gives us 2 to 3. So my scale factor is 2 to 3. My ratio of the surface area is going to be off of that, and it's going to be squared. So the ratio is 4 to 9. Now this is a big deal. Area is ratios are squared. Area scale factors are squared. Ratios are squared. And then the volume is cubed, and that is off of the original. 2 cubed is 8. 3 cubed is 27. All right. Now, when they give you the surface area, or any areas, okay, when they give you the surface area, what they have given you is the information to find that answer. If I am going to put the surface area ratio, because these are areas, and by the way, you know it's area because it's squared. your ratio for this is 25:4. Okay, so we went off of the surface area. I can use that to get this answer because I know that the surface area ratio is squared of this answer. So this would be 5:2. So that means the ratio of any of the parts in these figures would be 5:2. And then to get the volume ratios, I can cube that. 5 cubed is 125. It's 5 times 5 times 5. And 2 cubed is 8. All right. If you need to know your cubes really quick, 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And 6 cubed is 216. Anything above that, you can just multiply it out. All right. So now number 7, look what we have here. We have yards cubed. So these are volumes. So what's going to happen here is that information is going to give you the answer for the volume ratio. All right, so up here, I knew that didn't reduce, but we do need, I've got some pretty big numbers here, so we need to see if it reduces. So if I put 162 to 384, I'm going to check, and I'm going to see if it reduces. And looky there. Okay. Oh, by the way, they should be perfect cubes. Okay. So this reduces to 27/64. And that is our ratio here. That will give us the scale factor answer because all I have to do is say what cubed is 27, what cubed is 64. So my scale factor is 3:4, and then I can go off of that to get the area ratio, and the surface area ratio would be the squares, so 9:16. All right, so would you please get the answers for number 8? All right, I asked you for this answer right here, and so let me explain how I got that. These two are surface areas, so they are helping me get this answer here. I put the ratio of the left over the right, and it does reduce. If you still need help doing that in your calculator, let me know. So I did reduce it, and that answer went here. And I know that this is something squared. This is something squared. By the way, 64 is a square and a cube. It's a little pesky, so be careful that you didn't put 4 right here. If you put 4 right here, you missed that answer. Hopefully you figured it out because I didn't put a fake answer in there. That would be way off. So then you take the 8 to 5 and we cube those numbers to get the volume ratio. All right, 9, 10, 11, and 12. So now we have some problems that are almost exactly the same up here, but you have to just figure out what pieces they give you and what pieces you're trying to get. So I have highlighted the important pieces of the problem. Every one of these tell us that the figures are similar. We don't have to worry about them trying to trick us. It says the ratio of the heights of solid A. So if I'm talking about height, it is just a regular ratio, and that is 7:3. You know, one of the things about being a good math student is organizing your work. So this is me organizing my work. Find the ratio of the volumes, so that I know the volumes are the ratios cubed. And so that means I'm going to take 7 cubed, which is 343, and 3 cubed, which is 27. That is the ratio of the volumes. Okay. If you're wondering if that reduces, you can put it in your calculator and you can see if it reduces and it will tell you. Okay. All right, here we go. Number 10. So our figures are similar. The ratio of the surface area. So what they have given me is 16 to 1. All right, and it says what is the ratio of the radius? So that is just our linear measurements. And so I'm going to say what squared gives me 16, what squared gives me 1. So these aren't hard. You just have to figure out what they're asking you. Okay. Can you go ahead and figure out number 11 for me? Just kidding. I'll help you. Okay. It's a little different setup than these, but let's talk about it. So cylinder A has a diameter of 24. Cylinder B has a diameter of 30. They didn't give me a scale factor, but can't we use the diameters to get the scale factor? So you have just one extra step to get the scale factor. You have to use the 24 and the 30 and get that. Now go ahead and finish the problem. Here you go. So 24 to 30 reduces 4 to 5. And then it says, what is the ratio of the volumes? Volumes are cubed. And so that would be 64, 4 cubed. And then 5 cubed is 125. All right. So number 12, you're going to try again. And this one, I want you to remember, let's see what they're going from. They give you that you have a volume. And they say, what is the ratio of the surface area? So if you look back up here where I gave you a volume, look at the steps I had to take. I had to go from volume to the scale factor, then from the scale factor to my answer. So look at number 7 to figure out number 12. I'm going to ask you about the final answer, which is the ratio of these surface areas. You should have got 36 to 49. Okay, so they gave us the volumes. Obviously, that reduces. And these are not perfect cubes. So, guys, if it's not a cube, you can't get this answer, so you have to have cubes, okay? So we reduce so that we can have our cubes. And then I take what times what gives you 216. You honestly should memorize your cubes. And then 7 cubed is 343. Then I could take that answer and square it to get the surface area ratios. So my final answer is 36 to 49. All right. Turn over the paper. So let's just recall scale factor, A to B, surface area or two-dimensional area, A squared, B squared, A squared to B squared, and then volumes, A cubed to B cubed. Okay. Always reduce the ratio of the given measurements. And then if given surface area or volume, be sure you find the scale factor, which is A to B first, before finding the other answer. Okay. So question number 1, we're just going to practice again. It says if the cones are similar, what is the ratio of the surface area of the larger cone to the surface area of the smaller cone? What is the ratio? So this time they've given us a picture. They haven't given us a scale factor. They've given it to us in picture form. So it says from the larger to the smaller. So I can take 28 over 8, and that reduces to 7 over 2. That's your scale factor. So that means A to B is 7 to 2. Okay. What is the ratio of the surface area? That would be A squared to B squared, which would be 49 to 4. Okay, so see, we're doing the same exact thing. We are just in a different format. Okay, so just going to pick one for you to do. Let's do number 4. Okay, so there's your information. Your final answer is the regular scale factor. Go. Here you go. So we make a ratio out of 15 to 405. That reduces 1 to 27. cubes, which is kind of, oops, that should be 3, sorry. Cubes, which is kind of nice because my ratio of the volumes are cubed. And so that 1 to 27, 1 times 1 times 1 is 1, 3 times 3 times 3 is 27. Cube root of 27 is 3, cube root of 1 is 1. Okay? All right, so I think there's only so much I can give you. I think that's enough for you to get it. All right, so now flip to the next page. Starting here with number 7. I have prepared you for these problems in the fact that in this whole unit, we have cross-multiplied, we have solved for a value, and so now we're going to kind of put all that together. So follow me on this, okay? All right, let's break down the problem. Don't let word problems scare you. Just break it down and see what it's asking. The ratio of the diameters of 2 similar cylinders is 3 to 5. Okay, if it's the ratio of the diameters, this is what we've got. And you know that because that's not hard, okay? So the ratio of the diameters is 3 to 5. If the surface area of the smaller cylinder is 378 square inches, find the surface area of the larger cylinder. So we have to set up a proportion, but because it is dealing with surface area, we have to use the ratio of the squares to set up the proportion. So instead of using 3 to 5, I am going to use 9 to 25. And then it is just setting up a proportion and cross multiplying. So 2 cylinders, smaller to bigger, the surface area of the smaller, find the bigger. So we're going to say 9 over 25 equals, the smaller was 378, the bigger is what we're trying to find. You can't use the 3 to 5 because they have given us the areas. See how this all goes together? I love this. Okay, this is not something that you should have a lot of trouble with. All right, let's go ahead. I'm just going to give you a point for working that out. So go ahead and work that out for me. All right, there's your answer, and you know if you got it right or not. Number 8. The ratio of the surface areas is 16 to 9. Do you see how I'm taking the word problem and I'm just writing down what they give me? If the volume, stop right there. Can we go from area straight to volume? No, cannot. We have to go to the scale factor first, and then from the scale factor to the volumes. Do you guys get that? Okay, so we are using the ratios of the volumes to set up the proportion. Okay, let's do it. All right, so what would this ratio be of the linears? Well, if that's squared, 4 squared is 16, 3 squared is 9. What is the ratio of the volumes off of this one? 4 cubed is 64, 3 cubed is 27. This is what we're going to use in our problem. So the ratio of the surface area to similar pyramids is 6 to 9. Now the ratio of the areas is 64 to 27. The smaller one is 297. Which one of these represents the smaller one? Okay, so when I set up my proportion, the smaller one goes on the bottom, and we're solving for x. It's not hard, okay? I'm going to stop saying that because some of you are like, this is terrible. All right, I'm going to give you another point for the easy part. Work this out. There's your work. Ms. Ernsberger, do we have to put the units? Yes, you have to put the units. If I'm talking squared, put squared. If I'm talking volume, Area put squared, volume put cubed. All right, number 9. Prisms are similar. They have given us the volume. Find the value of x. Okay, so for this one, the value of x, look at the picture. It is represented by a linear side. So we are going to have to use the ratio of the linears to get that answer. We are given the volume, so I'm going to let you do this by yourself. Final answer. Okay, so I'm going to ask you what the final answer is. You are starting with what they gave you with the volumes, and then you will figure out, oh, I tell y'all too much. Okay, just like we've done, this is what you'll use in the problem. Go for it. There you go. Okay, so I made a ratio out of the 840 and the 105. That reduces to 8:1. And then to get the linear, the proportion with the linears, that's going to be 2:1. 2 cubed is 8. 1 cubed is 1. So then leftover right equals leftover right. 2/1 equals 20/x. 10 is your answer. Okay. All right, let's do this last one. I won't ask you a question, but let's just make sure you've got it. So cone A and cone B are similar, and it says the surface area. So we're starting with area is 108. That is area squared. Okay, so that's going to be 108 to 147. Okay, and then we're going to reduce that because that doesn't help us at all. And if I reduce it, it reduces down to 36 to 49, which is kind of nice because those are perfect squares. The question says we're going from area to volume. So I have to go to my linears first, which is going to be 6 to 7. And then from my linears to my ratio of the volumes, which are cubed, and that is 6 cubed is 216, 7 cubed is 343. Now we're ready to set up the problem. It says the volume of cone B. B is represented by the second one because it went A to B. And so cone B is 857.5. Find the volume of cone A. So we're going to say 216 over 343 equals x over 857.5. A to B, A to B. And then if you cross multiplied and work that out, and we are in volume, so millimeters cubed. All right. We are doing this together in class, so you're done with the notes. Okay. You got it. You guys are going to have an easy time doing the worksheet because these notes were spot on and very, very detailed. Okay, thank you.